FMS, Flight Management System. The FMS is designed to provide continuous automatic navigation guidance and performance management. It was first introduced on the Boeing 737-200 in 1979 as the Performance Data Computer System. The flight management computer was a huge technological step forward. Smiths Industries has supplied all FMCs installed on the 737. The Performance Data Computer System was developed jointly by Boeing and Ziegler in the late 70s. It enabled engine pressure ratios and airspeed indicator bugs to be set by the computer and advise on the optimum flight level, all for best fuel economy. It was trialled on two in-service aircraft, a 727 and a 737, for 9 months in 1978, with regular line crews and a flight data observer. The 737 showed average fuel savings of nearly 3%. The 727 gave a 4% fuel saving because of its longer sector lengths. The Performance Data Computer then quickly became standard fit, and many were also retrofitted. By 1982, the autothrottle had been devised, and thrust levers could be automatically driven to the values specified by the Performance Data Computer. The true FMC, Flight Management Computer, was introduced with the Boeing 737-300 in 1984. This kept the performance database and functions, but also added a navigation database, which interacts with the autopilot and flight director, autothrottle and inertial reference systems. The integrated system is known as the Flight Management System, FMS, of which the FMC is just one component. Most aircraft have just one FMC, but there's an option to have two, and in this case it's only taken by operators in MMPS airspace, for example oceanic areas. The FMS can be defined as being capable of four-dimensional area navigation, latitude, longitude, altitude and time, while optimizing performance to achieve the most economical flight possible. The components of the FMS then are the Flight Management Computer and the Control Display Unit. The Control Display Unit is the pilot interface to the Flight Management Computer. There are normally two CDUs, but only one FMC. Think of it as having two keyboards connected to one PC. The navigation database is used to store route information, with which the autopilot will fly when in LNAV mode. When given data such as zero fuel weight and maximum authorized takeoff weight, it takes inputs from the fuel summation unit to give a gross weight and best speeds for climb, cruise, descent, holding, approach, drift down, etc. These speeds can all be flown directly by the autopilot and autothrottle in VNAV mode. It will also compute the aircraft's position based upon inputs from the IRS's GPS and radio position updating. Here's one of the first pages. Initialization Reference Index. From here, using the keys on the left, 1, 2, 3, 4, 5, 6 of them, these are referred to as line select keys. On the left, line select key 1 is ident, line select key 2 is position, line select key 3 is performance, line select key 4 is takeoff, line select key 5 is approach, and line select key 6 is offset. On the right hand side there's also line select keys 1 down to 6. Ident then has the model of the aircraft, in this case a 737-800, shows the engine rating and the nav data what's active, and another data set to toggle with. This is showing one of two pages as signified by the top right corner. Line select 6 left is index, and line select 6 right is position initialization. So this is position initialization. It's page 1 of 3. It shows the last position, and information can be put in for a reference airport and a gate. Line select key 6 left will take you back to the index. Line select key 6 right will take you onto your route. Here's position ref, page 2 of 3. And you can see a variety of positions. Flight management computed position, IRS left position, IRS right position, GPS left position, GPS right position, and radio updated position. The pilot could choose any one of these, which one he feels or she feels is the most accurate for use. This is the route page, page 1 of 3. Act means the active route. If you make any change to it, it will change to mod route. The origin here, Stansted, with the flight plan and the destination, Dublin. Clicking onto page 2 of the active route, you can see the course that the aircraft is going to take. On the legs page, there's one of 5 pages shown here, and it's more detailed information of the route, showing details such as distances, speeds, and optimum levels to fly at. You can see bottom left is required navigation performance, which is required, and the actual navigation performance being achieved. Here's the cruise page. It's an active Econ cruise, page 1 of 1. There are quick buttons on line select key 5 right for engine out, and line select key 6 left for long range cruise. Here's the descent page, showing an Econ path descent. This is the progress page, page 1 of 4, and it shows data from the altitude, the actual time of arrival, the fuel, the estimated time of arrival for the next waypoint, and the fuel status as the flight progresses. Also bottom left, you can see the direction of the wind and the wind speed. Here's page 2 of the flight progress page, showing headwind and crosswind components, cross-track errors, and true airspeed. Here's RMP progress, page 4 of 4. Just more detail of actual and required performance. This is the N1 limit page, 1 of 1. So these are values which in all honesty the autopilot will select, but via the flight management system for the go around, economy, climb or cruise. These are percent N1 values which would be set. Here's the departure arrivals page. So you can click line select key 1 to edit the departure, line select key 1 and 2 right, that is, for the arrivals. And looking more closely at the departures page, these are standard instrument departures, SIDS, leaving Stansted. These are the arrivals at Dublin. So it's all there to be selected because it's programmed into the navigation database. The ones that are active have got ACT next to them.